Hello everyone and welcome to another Maths tutorial video. Now I'm going to discuss Form 5 Additional Mathematics Chapter 3 Integration Part 3 video. By the way guys, in this video I'm going to discuss two questions of integration which involves the concept of integration as a summation of volume. Before I begin, if you are new to any of my videos, please do subscribe to my channel and hit the notification bell as I'll be discussing more mathematics tutorial videos in the future. Alright guys, without further delay, let's jump to the question now. Okay, as you are looking right now is the example 5, chapter 3 integration. So let's read the question together. The diagram shows part of the curve 3y equals to 5 in a bracket x squared minus 1. So as you can see here, this is the curve which has the function 3y equals to 5 in a bracket x squared minus 1, which is on the top you have a horizontal line with the function y is equals to k, and then on the bottom you have a coordinate 1 0 as our x-intercept. Okay, continue to read the remaining question. If the volume generated when the shaded region is revolved through 360 degree about the y-axis is 25 over 2 pi units cube, find the value of k. Alright guys, usually what type integration question we will encounter is the question will provide us with the limit value and then the function, and we just immediately straightforward we solve the integration question. It can be either to find the area or to find the volume, but then this question is the other way around guys. So the question, they already give us the volume and then we need to find the limit value. Alright guys, I hope you will attempt this question in the future. If you could manage to solve this question, well done guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. Alright guys, let's start to show the solution. Okay, to solve this question, the step 1 we need to do is we need to change the expression of y into x squared in terms of y. So y we need to change into x squared. As you see in the question, this shaded area is revolved. This shaded area is generated the volume 360 degree about the y-axis. So they have already give the function in terms of y in terms of x. So now we need to change x in terms of y. But then we are finding volume here, so we need to find it x squared in terms of y. Okay, let us continue. So it's given as 3y equals to 5 in a bracket x squared minus 1. So what we're going to do, we're going to expand in the 5. Or you can do 3y equals to 5 in a bracket x squared minus 1. You can divide the 5 or you can expand in and then later on you can do the division. It's up to you guys. So what I'm going to do now, I'm going to expand in the 5 first. So 3y is equals to 5x squared minus 5. So from here, the negative 5 in the right hand side, you can bring it over to the left hand side. So from here you get 5x squared is equals to 3y plus 5. So to find the x squared, it's very simple. You just divide the equation by 5. So x squared is equals to 3y plus 5 over 5. So we have already changed the expression of y into x squared in terms of y. Okay, we have already done with our step 1. Let's proceed with the step 2. So step 2, proceed to volume generated formula. Okay, we need to identify which type of formula we need to use, because there is a two type of formula guys. We need to find in terms of x and in terms of y. For now, in terms of y, we need to use this. So volume of y is equals to pi with the limit, pi integration of upper limit b and lower limit a, x squared with respect to dy. If we want to find in terms of x, the only thing will be different is we need to find y squared with respect to dx. That is for volume x, but then we are now finding volume y. So we need to use x squared with respect to dy guys. Alright guys, I'm going to show you the remaining working in the next page. So we have already finished the step 2 by the way. Okay, proceed with the step 3. What we're going to do now is we're going to use the value of the volume, which is 25 over 2 pi units cube, to find the value of k. So proceed to the calculation. So we're going to use the volume formula, which is pi with the limit, with the integration k as the upper limit and 0 as the lower limit, x square with respect to dy. In this case, our x square is equals to 3y plus 5 divided by 5 with respect to dy is equals to 25 over 2 pi. So as you observe right here, there is a pi and pi in the left hand side and right hand side. So what we can do is we can cancel off the pi to simplify the calculation, and then from here we can proceed to the next step. So this 3y plus 5 divided by 5 we can break down into two components, which is 3 over 5y plus 1. So it will be easier for us to solve the integration, guys. So with respect to dy, which is equals to 25 over 2. Okay, let us continue. So from here, we can proceed directly to solve our integration. So 3 over 5y, the y will be increased the power by 1. So you'll get 3 over 5y square, and the 2 you need to divide as well. So 3 over 5y square divided by 2. So from here, you will get your answer is 3 over 10y square. So your 1, when you increase your power by 1, which is in the y power of 0, you will get back, you will get your answer in y with the limit of k and 0 equals to 25 over 2. Proceed to the next step. So as I said in the explanation, you will get here 3 over 10 y square plus y with the limit of k0 is equal to 25 over 2. So what we're going to do now is we're going to substitute in the upper limit value and the lower limit value, and then we're going to compare it with the 25 over 2. Okay, proceed to the next step. So we have already substituted in the upper limit value and the lower limit value. So 3 over 10 k square plus k minus with the lower limit value, which is 0. 3 over 10 times with 0 plus with 0, you will get back 0, guys. That's why I straightly put here minus 0 is equals to 25 over 2. Alright guys, if you observe here, we are actually forming a quadratic equation. So that means you will have two possible answers over here. Okay, let us continue to the next step. So you bring the 25 over 2 from the right hand side to the left hand side. So from here you get 3k square over 10 plus k minus 25 over 2 is equals to 0. Okay, now we have a quadratic equation. So the first thing we need to do to solve this quadratic equation is we need to eliminate the fraction. So what we can do is we can times the whole equation by 10. So from here you get 3k square plus 10k minus 125 is equals to 0. Okay, proceed to the next step. So proceed to the next step, we can continue to do our factorization. From here we get 3k plus 25 in the bracket k minus 5 equals to 0. Okay, proceed to the solution. Okay, since k value is in the positive y-axis, so you will get k is equals to 5 and k is not equals to negative 25 over 3. Okay, which is makes sense, guys. You get here two values, 3k plus 25 and then k minus 5. So from here you get your k is equals to negative 25 over 3 and then k is equals to 5. So if you look in the question, so the y is actually in the positive axis. Y equals to k is in the positive y-axis. It's not in the negative region, guys. So the answer which is suitable with the condition is k is equals to 5. K cannot be equals to negative 25 over 3. Alright guys, we have already finished explained the example 5. Now I'm going to proceed with the example 6. Okay, welcome back. Okay, let's discuss the example 6 now. The diagram shows the curve y equals to x in the bracket 4 minus x. P is the maximum point, as you can see here. So y is equals to x in the bracket 4 minus x. This is the curve function, and there is a straight line intersecting the curve, and this point P is the maximum point over here. Continue to read the question. Calculate the volume of the solid generated when the shaded region is revolved through 360 degree about the x-axis. So in the example 5, we solve in terms of y-axis. And now in this question, we are going to solve in terms of x-axis. Okay, let us proceed to the solution. Okay, the first step we need to do is, it's pretty similar with the step which we done in the example 5. It's just the only thing is we need to change the expression of y to y square in terms of x. Okay, so it's given here y equals to x in a bracket 4 minus x. So we're going to expand in the x. So from here you get y equals to 4x minus x square. But you still need to find the y square. So to find the y square, what we're going to do? So we're going to expand in the, we're going to square the y. So y square equals to 4x minus x square over here. So from here you get your y square equals to 16x square minus 8x cubed plus x to the power of 4. So this is your y square expression, guys. So we have already solved the step 1, which is change the expression of y to y square in terms of x. So proceed to the next step. Okay, the step 2 is we need to find the coordinate of P. So the question already mentioned that P is the maximum point, and you've already find the the question already gave us the y function which is equals to 4x minus x square. So how are we going to find the P coordinate, guys? So I'm going to explain to you now. It's given that y is equals to 4x minus x square. So one thing you should know, guys, the curve P is the maximum point. So how to find the maximum point? So well, we are going to use the differentiation knowledge here. What we're going to do is we're going to differentiate this y function, and then we're going to set it to the turning point where your dy dx equals to 0, and then from there we're going to find our maximum the coordinate of P. Okay, let us continue. So we already differentiate this y function. Dy dx equals to 4 minus 2x, and then we're going to set our dy dx equals to 0 to find the maximum point. You can even call it as a turning point as well. The turning point is the point where your dy dx equals to 0, where your gradient of the tangent will be in the horizontal line. Okay, let us continue. So the gradient of the tangent, so 2x minus 4 is equals to 0. So 2x equals to 4, where you get your x equals to 2. So x equals to 2 is your coordinate where your dy dx will be equals to 0, guys. So from here, when x equals to 2, so we have already get the x coordinate. So to find the y coordinate, what we do, we substitute back into the y function. So when x equals to 2, so y equals to 4, we substitute the 2 value here. 4 times 2 minus 2 square. So you'll get your y value is equals to 4. Okay, guys, I'm going to explain you the remaining step in the next page. Okay, so it's given that the coordinate P is 2, 4. So we have already find the maximum point. So proceed with the step 3. So the step 3 is we need to form the straight line equation OP, and then we're going to express the straight line equation from y to y square in terms of x. Since we are finding the volume, guys, so if we are finding the area, then we no need to change to y square. So let us proceed. But before that, we need to find the gradient of the graph. So the formula to find the gradient of the graph is m equals to y2 minus y1 divided by x2 minus x1. Okay. So in the question, they've already given us the x-intercept value, which is 2 and 0. And then, sorry guys, the origin is the first coordinate, and then the coordinate P is the second coordinate we got. So we can use that to find the gradient of the graph. So we can calculate 4 minus 0 divided by 2 minus 0. So from here, 4 divided by 2, you will get your answer is 2. So your gradient of the graph is 2. By the way, sorry guys for the wrong explanation. So 0, 0 is your origin, and then your 4, 2 is your second point, which is in the form of straight line OP. So the gradient of the straight line OP is 2. Okay, proceed to the next step. So we need to form the straight line equation. So for that we will be using the formula y minus y1 equals to m x minus x1. Okay, so we can use either point. We can use our origin coordinate, or you can use the coordinate 2, 4. So in this case I'm using the coordinate 2, 4. So y minus 4 equals to 2 in a bracket x minus 2. So you're expanding the 2. So you get y minus 4 equals to 2x plus 4. So the negative 4, negative 4 you can cancel out. So you should get your y is equals to 2x. So this is your straight line function, guys. So but then this is not the full working. You need to change it into y square. So in terms of y square, you need to square this whole function. So y square is equals to 4x square. Alright guys, so proceed to the next step. So once you have already finished all the 3 steps, so now we can proceed to calculate the volume. So how are we going to calculate the volume, guys? So I'm going to show you the diagram now. Okay, as from the question, so this is the curve and this is the straight line from the origin to the point P. So this is the point P, guys. So the volume generated will be from the curve, and then you have to minus from the straight line, guys. So how are we going to find the volume of the shaded region? So I'm going to show you. The volume of the shaded region is equals to volume of the curve minus the volume of the cone. Sorry, minus the volume of the cone. Now you might be asking me, why volume of the cone? Okay, now if you notice carefully, as I draw the line here, it's actually forming a cone. It's an imaginary shape of a cone. So imagine your straight line is revolving 360 degrees. So it's actually forming a cone, guys. Volume, imaginary volume. So to find the shaded region, the big area volume of the cone, volume of the curve minus with the volume of the cone. So then only you get the shaded shaded volume, guys. Okay. Proceed to the next step. So from here we're going to use the volume of x is equals to pi times with the integration of limit b, upper limit b and lower limit a, y square with respect to dx. Okay, now we can proceed to calculate the integration. So we have already find the y square for the curve and then the y square for the straight line. But then for the straight line we no need to calculate the y square. So we can use straightly to calculate the volume of the cone. So what is the volume of the cone? 1 over 3 pi r square h. So in this case, our radius is actually the y-axis, guys, which is the 4 over here. And the h is actually the x-axis, which is the 2 over here. So if you notice carefully, the 4 is actually the radius and 2 actually is the height. So that's why we immediately minus with the volume of the cone. So minus 1 over 3 pi r square h. So your r is 4 and your h is 2. So in this case, we have already find the y square function for the cone. So 16x square minus 8x cube plus x to the power of 4 dx with the limit of 2, 0. Okay, now we can proceed to calculate. Okay, from here you get 16x cube divided by 3 minus 2x4 plus x power of 5 over 5 with the limit of 2, 0 minus with 32 over 3 pi. So the volume of the cone you get is 32 over 3 pi, guys. So what you do is, for the next step, you substitute in the upper limit and the lower limit value. Okay, from here you get pi in a bracket 16 times 2 power of 3 divided by 3 minus 2 in a bracket 2 power of 4 plus in a bracket 2 power of 5 over 5 close bracket minus 0, and then you minus with 32 over 3 pi. Okay guys, we are very close to the final answer. So from here you get the volume of the curve is 256 over 15 pi, and then the volume of the cone is 32 over 3 pi. So you minus them, you should be getting your answer is 32 over 5 pi units cube. So this is your final answer, guys. Alright guys, that is all for my discussion of step-by-step working and solution for this question. Any questions or feedback, feel free to put in the comment section below. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please do click the subscribe button and hit the notification icon as well. Alright guys, thank you everyone for your support, and I will see you in the next video.